Welcome to Breadboarding. This is video 36 in the Breadboard 8088 PC series, and in this video I'm going to show you how to boot and run PC-DOS 2.1 using the debug version of MS-DOS 4 that we were covering in the previous two videos. So in this project we've been building a basic floppy disk PC on solderless breadboards, and in the previous two videos down the bottom here we built MS-DOS 4 and 4.0.1 patched version from source code, and also built it on MS-DOS 3.3 as well. Now we did that so we could actually build a debug version of MS-DOS so we could get more messages output to the display during power on. And what we're going to be doing in this video is going back to booting DOS and seeing if we then actually run up DOS fully from floppy disk. Now we will be using PC-DOS 2.1 and I'll explain the reason for that later. So in the previous two videos, 34 and 35, we built out MS-DOS 4.0.0 and 4.0.1 from source code, and what this will allow us to do now is to build out the io.sys and MS-DOS sys with debug messages. Now there are a number of blogs on how to build from source, and if you cover either of these links or you cover videos 34, 35, shall include links at the top up here or down in the description below, and that will tell you how to build MS-DOS from source code. Now to enable the debug messages, then many files have itest equals 0, so it's just necessary to change those lines to itest equals 1, and that will control whether or not the debug macros include the message information. And there's also the msbdata.inc has a setting for the test bits, and if we set the test bits here to ftest all, that will enable all debug messages. Now when building this, there are some jumps and conditional jumps go out of range when the extra message macro code's included. There are a few jumps that go out of range, and I'll just show you some of the changes done in WinMerge, and you'll see that there's a few places where you have to make a few tweaks and things to get the code to compile with the messages in. So what I have here is a comparison of my current working source code with the original source code I had on the ISO CD, so that's just the patched for 4.0.1 but without any of these changes. So I'm just going to take you very quickly through these changes. So you'll see that within here that there are a few areas where I had to change the jumps here, so it won't assemble with debug if the jump's out of range. So there's a few areas where we've had to do minor changes like that, but the majority of these things just have the itest equals 1 to replace the itest equals 0, and this was the one here where we control the level of output messages, so we can have ftest all, just the initialization, just the disk. There are various scopes that you can include in here, and if you look in the source code you'll see how you can turn that on and off. And then most of the rest of these files have just got the itest 1 enabled. Now there's a part of the initialization code here you'll also see, I'll explain in a minute, that I commented out some of the messages, certainly the COM devices and LPT devices, because I didn't actually have any of those on the breadboard computer at the moment, and there are a few other things I moved around, but that was primarily to adjust the order of which the messages were coming out, and I'll explain why that was an issue in a minute. And then there's another thing here, we need to change the jumps so that we didn't get jump out of range, and then this was just the path being put at the end to avoid link problems. Okay, so I built all of that. I'm not going to show the whole process of how to build that, make a floppy disk image and all that sort of stuff, because I did that over the previous two videos. The upshot of all that is that once you do all that, what I did was first of all booted the breadboard PC off that debug MS-DOS 4 floppy disk, and what you'll see here, it got a reasonable amount of the way. So we got the initial IBM BIOS in it, LPT, COM devices, various other things, but then it got down to the hard disk one where there isn't obviously a hard disk installed here, and it just stopped. So the booting freezes when it gets down to row 24. So what I then did is I tried the same image and I actually ran it on VMware version, so I was able to actually capture some of the screenshots a little more easily. And so what you can see here, we get similar sort of messages coming down, and then we got a lot more detailed information coming down as we go here, and this is all of the file allocation table, I think, following the file allocation table. And then finally we get all the way down here, and it actually pauses for keyboard entry before calling sysinit. This was the level of information that I was expecting to actually get, And obviously, because the breadboard PC was kind of stopping as it got to the bottom of the screen, I had a look into the background of why that could be. Now, the BIOS we're using is Sergei Kiselev's 8088 BIOS. That's been absolutely great. I can't speak highly enough of it. But there was a particular issue that in the video driver code that I found that it only really supports CGA video cards, or if you have a monochrome display adapter like we've got in the breadboard PC and a CGA card, it will work if they're installed together. However, because the interrupt 10 video routines wait for a horizontal sync or vertical sync on the CGA status port for anti-snow handling, this is to avoid the interference on the screen during updates by the CPU, what happens then is it hangs forever whenever the MDA video card is expected to scroll the screen using the BIOS. And this was because the CGA status port obviously is a completely different port from the status report from the MDA card, and the MDA card doesn't have the same available horizontal sync, vertical sync lines that the CGA one does. So what I needed to do is to go through and update the BIOS to ignore the retrace wait routines when running in video mode 7, so that's the monochrome display adapter, and these were the routines that needed modification. And in fact what was happening is as part of the scroll up or scroll down, it was also reading character attributes and writing character attributes, and so all of these things had these retrace wait routines, and this would cause the whole PC just to lock up because there was never ever going to be any signals coming back from those ports because it doesn't have that port. So if we have a look at the files that were needed to be changed, so this is a comparison of the BIOS files, and in fact although these are all the changes that have been done compared to the default version, but if we look at the video BIOS here, there are some changes here that we've done already as part of adding the VGA palette support and a few debug messages, and our machine specific, the VGA compatible timing signals that we need for driving a VGA compatible monitor, our VGA palette information. But then here we've got the code that says this is called for MDA as well as CGA, but uses a CGA status register. So basically it will hang forever. So what we're doing here is including a comparison. So say if we're using video mode 7, which is MDA, then we avoid doing the retrace step, so waiting for retrace. So we basically just skip over the code that's waiting for the retrace values to be on the port, and we have to do that for a number of these. So there was the reading, the writing, and the writing character only and writing attributes. So with those changes, and I rebuilt that and then updated the BIOS EPROM, that's all been put into the breadboard PC. And so what that should now mean is when we get to the bottom of the screen, we should now be able to scroll. So in fact, this is a screenshot from a session that I did earlier. And what we can now see is that we actually get a lot more messages going all the way down to the sysinit. I actually captured this off a video that I captured of the updates here. Unfortunately, the screen updates go through quite quickly, so it's difficult to capture cleanly. And what we can see here is now pausing on the sysinit. Now, DOS4 still doesn't boot properly after that sysinit stage. However, I am looking into that and I'll hopefully find out the reason why. I think it's to do with the floppy disk drive change disk detection, which seems to be quite complicated in MS-DOS 3.3 and MS-DOS 4 upwards. So now what we're going to do is to start up the breadboard PC, and we'll switch over to the video capture and we'll have a look at running up PC-DOS 2.1. So it's powered on. Now I'm just going to boot it into the BIOS. Just need to put in today's date and time. And there we have it. We now have PC-DOS running. Now when I did this previously, it appeared to hang. Now the reason is because the retrace wait was just looking for the CGA port only for the horizontal sync, vertical sync, then that was why it was hanging. So now with the BIOS updates that I've done, we should now actually be able to do clear screen, can do version, do dir/w, dir full directory listing. Well, you can see now that everything's scrolling okay. Now there's still a few other things that I need to look into. At the moment, if I try and run basic, for example, then it comes up with a divide error. So I need to look into that. But at the moment, the other utilities are working. So if we run fdisk, it will tell us that we don't have a hard disk. No fixed disk present. And because the floppy disk has been write protected, then I can't really do very much else. But I can see that PC-DOS is working, and so what I will be doing over the next couple of days is doing a little bit more on this, and hopefully I'll do an update where we can actually get the later versions of DOS working. So we have it, we've got the breadboard PC running PC-DOS 2.10. Now I think the reason why PC-DOS 2.10 works whereas later versions don't is that there were quite a lot of changes made to the source code from looking at the MS-DOS 4 source to do with high density floppy disk drives, so in particular the 1.2 meg drives and the 1.44 meg drives, and I suspect that is actually causing some problems once the initial startup of MS-DOS happens and it starts to use the ms-dos.sys. That seems to be causing a problem. So with this newfound debug capability, I'm going to do some more debugging on that and hopefully get to the bottom of that, and we'll be able to boot later versions of DOS such as 3.3.0 and 4.0.1 that we've been looking at. What I will be doing in the next video is probably doing a summary of the Breadboard PC project so far, so this will hopefully be a fairly high level summary of what's gone on and show the board and explain what the different bits of the board are. So if you don't want to miss out on future videos, please hit subscribe, and if you found the content interesting, please hit like. It just helps to make the videos available to a wider number of people. Thanks for watching.